So for question 9 of exercise 6.2, the thing that we're introducing here is the idea of correspondence. Now, when we're talking about correspondence, what we're doing is we're looking at a ratio of x values to y values. Now, we can have a one-to-many, we can have a one-to-one, we can have a many-to-one correspondence, we can have a one-to-many, or we can have a many-to-many, or not many-to-many, many-to-many. I'll draw up the others when I see how much space this takes. But basically, a one-to-one, each x value has its own y value. So 1x, so that means that we've got one x value for one y value. Now those types of graphs that we see are things like your linear, whether it's that way, that way, that way, doesn't really, oh no, not quite that one, whether it's like that, or the other one is your cubics, your powers of 5 and things like that, which have what we call a point of inflection. They're all your one-to-ones. Now, your many-to-one is a little bit different. So your many-to-one means that we can have lots of x values, so a number of x values can correspond to one y value. So n to show numbers of x values. Now, those types of graphs are like these. So say we've got a parabola, for example, and here at the x-intercepts, what's our y value? Well, our y value is 0. Now, clearly we can have, it looks like it might be, I don't know, -1 here, and we've got another y value here of 3. Sorry, an x value there of 3. So here we've got two different x values. We have many x values corresponding to one y value, and that's what we see there. Now, as I said before, we can have one-to-many, and all these are relations, mind you. We'll talk about functions soon. We can have a one-to-many. Now, in a one-to-many means that we have one x value can correspond to many or a lot of y values. So that happens with things like our sideways parabolas, or things like a little bit more extreme, things which do this. That's where you can have our one-to-many. So basically, like I said there, we can choose an x value. Here we can say we've got x equals 0, or here we've got x equals, say, 5. And if we look, x equals 0 at this point and this point. So we've got one x value, x equals 0, but we've got two y values. Here we've got one x value, but we've got lots of y values there. So that's our one-to-many, one x value to lots of y values. Alright, now the last one we're going to have a look at is this idea of many-to-many. Now in this, lots of x values have lots of y values possible. Now these happen with things like circles. And with a circle, we can have, say, an x value here of -2, which corresponds to a y value of 2. We can also have another x value of -2, which corresponds to a y value of -2. Then from there, we could have, just have a look at over this side, we could have a x value here of 3, we could have an x value here of 3 and a y value of -1, and we could have another x value of 3 and a y value of 1. So we've got many x values, relating to the same y value. And it's just, I probably should have been better if I had done this as being 2 and 2 and then 2 and -2. Just so you see that we've got -2 can correspond to 2, -2 can correspond to -2, 2 can correspond to 2, 2 can correspond to -2. Just to show you that many different x values can correspond to many different y values. Now they're generally circles and ellipses and things like that. But that's the way we've got that. Now, these two things, these two here are relations, they are not functions, because they do not pass our vertical line test. Vertical line, not a function because it cuts through more than once, not a function because it cuts through more than once.